company, what you're doing?
Yeah, sure. So I'm Cesc Guim. I'm the Chief Executive Officer of OpenChip. Myself, so I go back 25 years ago. I did my PhD at Barcelona Supercomputing Center, and then just right after, I joined Intel for almost 20 years.
Intel, okay.
And in Intel, I've been doing lots of things. I started doing CPU architecture for almost 7 years, and then I moved into the HPC cloud data center design, including looking at the small kind of like the CPU, but the system design like chassis, racks, and whatnot. And the last 7 years, so I've been working. Well, I was working until 12 months ago in the network and edge division, and kind of looking at the interplay of the different products, deployment models, and vertical software, hardware, and whatnot. And about 10 months ago, I joined in OpenChip, which basically it's what we call corporate startup, based here in Barcelona. And basically what we are doing is developing RISC-V based technologies in basically trying to contribute into the European technology sovereignty. Okay, and
RISC-V based technologies.
Yes, RISC-V. Do you know what is RISC-V?
No.
Okay. So Intel is using the x86 ISA. No?
Yeah.
There's ARM that they have their own ISA. So basically, and all those ISAs come with a licensing model.
Yeah.
So you can't use it unless you have a license.
Yeah.
And you have to pay for it. So now the question with those ISAs, they are perfectly. It's a licit business model, but as a company, if you are developing your own processor, CPU, and whatnot, you are always bound into the licensability or not of those instruction sets. So basically, RISC-V is a instruction set architecture.
Yeah.
That is
so an architecture for chipsets, right?
Yeah, for chips. Yes.
Okay.
Similar to Intel or ARM.
And Qualcomm and that kind of stuff.
Anyone can use this instruction set.
Okay. So
and it's royalty free.
So OpenChip provides this architecture.
No, that's a standard organization. So it's a worldwide organization that defines this instruction set.
Okay, got it. Yeah.
And we are based on this instruction set. And we are based on this instruction set because it's an open standard that is not bound into a specific company. It's a royalty free. So and it's not bound into any license type.
Okay.
And that's very important because basically what this ISA allows you to do is to develop your own technology independently to sake of Intel, of ARM. You can do your own CPU with your instruction set. And the RISC-V is something that is taking quite a bit of traction worldwide because basically that gives to countries or to Europe, for example, the sovereignty of developing their own processors or CPUs based on this new instruction set. And we as a company, OpenChip, we're building our products based on RISC-V because that gives our technological independence in terms of the instruction set, and we can develop our products without depending on, let's say, Intel or ARM of licensing to us their CPU, and maybe at some point say, no, you can't use it anymore.
And is this then only for connected devices, or can it also be used for
anything?
Unconnected?
Well, actually, in our case, it can be used for any CPU. So and the chip itself.
Yeah.
Okay. And when you look at OpenChip now, we're working more on not that much on the IoT, to be honest, more on the high-end Nvidia type of appliances, so higher power.
Yeah.
But you can use the same thing for very small devices, okay? And you can chop it like the chip that we are doing, and instead of having a 600 watts CPU that goes in a data center, you can have one of those chops and use it for a small IoT device.
Okay, and completely different. You said something about it's a corporate startup. Why is it a corporate startup?
Yeah, that's a terminology I like to use because when you go, and this is public information. We got a NIPSI grant about 138 million and basically it's what I call corporate startup, because we are a startup, but we have to deliver like semiconductor products, which take we have to basically create a structure as a company that is similar to Intel or others in terms of the toolings that we have to use, IT like type of agreements that we have to use. So it's really you have to have a very advanced kind of structure and resources.
Okay, got it. And how important is IoT for OpenChip?
I mean, when you look, and because I come from the two sides, I mean, like technology in general, it's a continuum, no? And it's like I'm always talking about the edge to cloud continuum.
Yeah.
And basically for us, what we typically talk about is there is the part of the sensing, and there is the part of the act, no? Sensing, it's and the two go together.
Mm-hmm.
And you can do a very, like many of the customers that we talk with, I will talk about telcos and other players, they have some part of the processing that happens on the far edge in IoT gateways and stuff like that. But then part of the processing goes through the communication like network and then ends up being processed in the data center, no? So from OpenChip perspective, now we are not in the IoT space yet, but when we look at the kind of system design, we look at that at some point we will have like some devices on the far edge using our small, tiny processors with certain features about data protection, security, and whatnot. And the same type of processing will happen into the cloud. And then you now, as a customer, you can decide where to process things depending on the SLAs and stuff like that.
Okay. So you see it as something for the future?
Yeah, definitely. Okay. Yes.
And now you're here to set the
foundation. Set foundation, but also like talk with the industry, and I mean, giving a little bit of this perspective on like kind of the technology sovereignty that Europe needs more now than ever. And basically look at this, that it's not just only IoT or data center, it's a combination of the two. And it's important that when we look at the technologies, it's not kind of, we look at how these things go in, interlock together. Yeah. And that's what I want to talk about.
Great. Thanks a lot. It was awesome to learn more about OpenChip.
Okay, good.
Good luck.
I'll talk to you later.
Thank you.
Bye now.